Hello, everyone. I'm Ida Xu from Delft University of Technology. This is my presentation for SocialComm 2022, and my title is Adaptive Agent Network Models with Internal Mental Models Supporting Patient Safety. The terminology for safety has evolved from a focus on error to patient safety, and then to adapting a safety culture with adequate shared mental models. The mental model means a person's simulation of real-world events. The shared mental model means an overlap of the team members' mental model. Those two terms are shown in the graph. Both nurse and the doctor has a simulation of real-world process, and their mental model plus together overlapped form the team's shared mental model. Sometimes imperfect knowledge leads to imperfect shared mental models. Here, both doctor and the nurse lack some knowledge, and for some reason, they don't communicate effectively or they're afraid of authority. They don't have a good overlap of mental model. And the imperfect shared mental model will lead to bad results. And then the team members blame each other after medical operation fails, and those blame doesn't change anything. So this is blame culture. What we want is just culture. Team members distribute their duties justly, equally, to complete the task. So here we introduce an AI coach, try to help the team form a perfect shared mental model and improve their performance. Organizational learning. Organizational learning is defined as a change of organizational knowledge occurring as a function of experience. Currently, research on computational formalization of organizational learning is rare, so it's innovative to introduce computational formalization of organizational learning to this research. The bottom are a model of organizational learning. So individual and the organization transfer and deliver their knowledge. The application scenarios are neonatal resuscitation because these scenarios is not too complex. Yeah, with only one doctor and one nurse. And it's urgent, so it's important not waste time by making mistake. And University of Nottingham provide a teaching video. So this teaching video becomes the scenarios. So in neonatal resuscitation, medical teams give ventilation to the baby in danger, and that includes 3 steps: preparation, ventilation, and assessment. The ventilation have 2 kinds. The first kind is pure ventilation, and the second kind is the combination of compression and ventilation. The research method of this research is network-oriented modeling. This approach refers to modeling complex processes by networks. The approach provides a powerful tool to present states and the causal relations of those processes and over time. And Proef Jan Ter from Vrije University of Amsterdam designed a software environment helping analyze. So here is an example of using network modeling to model mental models. The bottom layer is use of mental models, and the second layer, adaptation of mental models, and the third layer, control of adaptation of mental models. So characteristics that define a networks are base connectivity. The number shows the strength of connections. And second, those connections plus together, there are a combination function. Combination functions used in this article are presented here. And to show time characteristics, we introduce a speed factor. For the purpose of simulation, networks should be transformed from graph form to numeric form. So the research object is to explore how AI technology can help increasing team performance for the medical team giving ventilation. The innovation points of this research is the research combined organizational learning, shared mental model, and their computational form with the help of network-oriented modeling, and shows how AI coach can contribute in increasing the team performance by helping the team form higher degree of shared mental model. So the main research question can be classified in two sub-questions. First, how AI coach can evolve without organizational learning, and how AI coach can evolve with organizational learning. We can see here, we give a high threshold value. Here, the nurse lack knowledge of pure ventilation. So the AI coach noticed the nurse is going to make mistake. So the AI coach warning the nurse. So the nurse know how to do pure ventilation correctly. And this process shows how AI coach helped the nurse. So the nurse first have a high value of threshold value for preparation that will stop the nurse mental state for preparation for pure ventilation activated. Then the AI coach noticed that, and then the AI coach warned the nurse. So a speed of so that's make the speed of the thresholds decreasing get activated. So this HT states control the decreasing speed of T states. So when HT states increase, that means T state will decrease. So the AI coach's action of warning make the nurse prepare well, because this increase and HT increase and T states decrease, and then the nurse mental model states for preparation of pure ventilation will increase. This graph shows the monitoring. We can see after doctor and nurse action, the corresponding AI coach's mental state will increase. Here shows the process of warning. At the beginning, the nurse doesn't prepare well, and then the AI coach warned the nurse, and then the nurse know she should do pure preparation quickly, correctly. So her preparation for pure ventilation increase and get activated. You can see the change happens here. And the second direction is adaptive network model for the AI coach engagement with organizational learning. Yeah, this is suitable for both team members have imperfect knowledge. The nurse have imperfect knowledge in preparing for pure ventilation. The doctor has imperfect knowledge for preparing the combination of compression and ventilation. They won't have effective communication without AI coach engagements. So this network going to show how AI coach can promote their communication. Step 1, the AI coach will learn from the doctor. And step 2, the nurse will learn from the AI coach. And third, the AI coach learn from the nurse. And fourth, the doctor learn from the AI coach. So in this way, their knowledge transfer quickly. Here has a context state control the upper layer. The upper layer means a bridge between team members and the AI coach. This graph shows the monitoring function. Monitoring. And here comes to the key part. How AI coach promotes communication. We can see in this graph, there are 4 context states control the beginning of feed-forward learning and feedback learning. So at the beginning, the doctor has a perfect knowledge for preparing pure ventilation. And the bridge from doctor to the AI coach activated very well at the beginning. So the AI coach gain perfect knowledge for pure preparation as well. So the AI coach have perfect knowledge for preparation of pure ventilation here. And when time equals to 5, the AI coach start giving knowledge to the nurse. We can see here the bridge was built, and then the nurse gained perfect knowledge for preparation of pure ventilation. And when times equal to 10, the nurse start giving knowledge to the AI coach. So we can see here, when time is around 20, the nurse is prepared well for the combination of compression and ventilation. So the AI coach quickly gains the knowledge from the nurse. And when T equals to 25, the bridge of AI coach give feedback learning to the doctor. The doctor learned the knowledge for combination of compression of ventilation from the nurse, from the AI coach quickly. So in the end, all team members gain perfect knowledge. So a perfect shared mental model was formed. So here are the discussion. Those 2 networks and their simulations show how AI coach can engage in current workflow. And so those networks show AI coach can prevent errors by monitoring, warning, and promoting knowledge transferring. Those answers how AI coach can help to improve. And there are some limitations. First, the research is mainly on simulation. Later, we can explore to expand to field experiments. And second, the team size is small. We can turn to bigger size, and the ventilation can turn to more difficult surgery as well. Thank you.